All right, in this problem we have two cab companies, a blue cab company and a green cab company. We have a plaintiff who wants to sue one of these cab companies based on what an eyewitness said about, I don't know, the blue cab hit him or the green cab hit him. What we're going to do, the best way to do this conditional probability is with a tree diagram. The tree diagram is going to look like this. Each endpoint, each node, will represent an event. Now, we know that, we're told that, there are two different types of cabs, like we said, blue and green. Furthermore, the eyewitness will sometimes say blue, or he will say green. Same thing regardless of whether the cab is green or blue. So he'll either say blue or say green. All right, once we've got our tree labeled with a certain nodes, and this can be the trickiest part, knowing how to order these is sometimes tricky. We're going to now label the edges with the associated probabilities. Now for the problem that I've created, we know that there are 30% blue cabs and there are 70% green cabs. Furthermore, the eyewitness is right only 90% of the time. That is to say, if the cab is blue, he'll correctly identify it as blue 90% of the time, but incorrectly identify it as green 10% of the time. And now those numbers get flipped as we move down to the second part of our tree. If the cab was green, he's going to say it's blue 10% of the time, but he's going to correctly identify it as green because it's green, so he's going to say green 90% of the time. Once we have our tree filled out with all the nodes and all the edges labeled with probabilities, we then multiply down the edges to get the associated total probability. That is to say, we're going to take this 0.3 and this 0.9 and multiply them together to get the probability of this event. So we have 0.3 times 0.9 is 0.27. Then we have 0.3 times 0.1, that's 0.03. We have 0.7 times 0.1, that's 0.07. And 0.7 times 0.9 is 0.63. Now, the question is, once we have this table set up, we can very easily answer the next question, which is the following. What is the probability that the cab was blue? Given, so this little vertical bar means given that the eyewitness said blue, okay? So what's the probability the cab is blue given that the eyewitness said it was blue? Well, we're going to use this by looking at these endpoint probabilities to figure out where our numerator, what's on our numerator, what's in our denominator. So this formula is probability of, I'm probably running out of room here. Let's scoot this down a bit. We have probability of blue and said blue divided by probability that he said blue. This is just straight formula for conditional probability. If I say P of B given SB, these events, B and SB, go right in those positions regardless of what we have. We could have pizza emoji and eggplant emoji right here. We're just going to replace those things by what we see in this formula. Where do I get these values? Where do I find P of B intersect SB and P of SB? Let's start with P of SB. That's actually easiest to start with. P of SB are all of these values, the sum of all the values who have SB next to them. So if you'll notice, 0.27 has SB next to it. So that's going to be in our denominator. Furthermore, we have 0.07 also in our denominator that's next to an SB. So this is going to be added. Notice that this 0.03 and this 0.63 have SG next to them, so those don't get included in our denominator because we're looking for P of SB. Now, the numerator, P of B intersect SB, is the one SB term that is also part of the B tree. So notice that this SB is part of the G segment of our tree. We're not going to count that in our numerator. This SB, however, is part of our B tree. So 0.27 is our numerator. 0.27 divided by 0.27 plus 0.07, you can say this is 0.27 over 0.34, and that's going to give us an answer of 0.794. And that is your final answer.